I want to show you the basics of exponents and how they fit into the order of operations. Let's start with multiplication. You know, multiplication actually, 5 times 3, what does that mean? Multiplication,
Do you mind telling me what this is all about, mister?
is actually multiple addition, isn't it? You don't see a 3, but it's 5 plus 5 plus 5 3 times. That's what multiplication is, multiple addition. You knew that already.
And now for something completely different.
Exponents are not multiple addition. Exponents, they go up here, mean multiple multiplication. So we're not going to get 15 here. Going to get 5 times 5. That's 25. Take that answer and multiply that times 5, and you get hugely different answer, 125.
Alrighty then.
Let's do another one. 3 to the 4th power, 3 to the exponent of 4, really means 3 times 3, get 9, times 3, get 27. Take that times 3, it's getting harder now, and get 81. So we got, where's the 4? Well, there's 4 3's multiplied. And that's your answer.
I don't understand.
Okay, let's try another example. How about 2 to the exponent 5? Okay, we're going to multiply 2. Guess how many times? All right, 5 times. Of course, we're going to have to get an answer each time and then multiply it by 2. So we'll go 2 times 2. We'll get 4. Take that times 2. 4 times 2 is 8. Times 2. 8 times 2 is 16. Times 2. And guess what? 2 to the 5th power is...
Excellent.
32.
Think you'll come again.
Let's do another one. Let's do 5 to the 3rd power.
It's very simple, sir.
There's 3 5's, isn't there? But you have to get an answer each time and then move forward. We have 5 times 5, we get 25. Take 25 and multiply it times 5, and we get...
How do I do it?
It's not so bad, is it?
Whoa!
How about something like this? Well, let's do them separately. 4 to the 2th power, or 4 to the 2nd, or 4 squared, sometimes it's called, just means 4 times 4. 1 to the 4th power, now this is where people screw up. That's not going to be 4, is it? 1 to the 4th power is 1 multiplied by itself 4 times. Now let's once again break this up. 4 times 4 is 16. Now be careful. What's 1 times 1 times 1 times 1? It's 1. You can have a bunch of 1s. They still end up being 1. And 16 times 1, of course, is 16.
I know you are, but what am I?
What about 1 as an exponent? It could happen. 5 to the 1 power. What do we do with that? Well, we write 5 one time. So don't make this difficult. The answer is just 5. So anything to the 1th power is just itself. Okay? I just want to make sure if you see that, you don't get baffled. Now let's talk about operators and terms, because I'm going to be talking about the order of operations in just a second, and I need you to know what these words mean. Operators are they do just what they say. They operate. They do things. The operators are times, plus, division, subtraction, etc. In this picture, the operators are blue. The things that get operated upon are terms. 12 is a term. 5 is a term. 3 is a term. They're operated on by, and 6 is a term, by the operators. Okay? Big deal. Well,
There's something I have to ask you.
consider this. What is the answer to this question? 5 plus 7 times 10. Is it 5 plus 7, get a 12, and then take that answer and multiply it by 10 and get 120. Seems obvious, doesn't it? Or is it 5 plus 70, multiply the 7 times the 10, and then add them up and get 75. As you can see, it matters what order I do them. Which do I do first? Do I do the operator of plus first, or do I do the operator of times first? Or do I just always work from left to right? Or what's the deal? I need to know what the order, the allowed order that I'm supposed to do operations or operators in. And everyone has to do them the same, or as you can see, you're going to get different answers.
Here's someone who can help you.
This is the order of operations, and this is the way it shall be, whether you like it or not. In every problem, you'll have to do, obviously, what's inside parentheses first. And if there's more than one parentheses, you'll work from left to right. Then you'll do any exponents. And if there's more than one exponent, you'll work amongst those exponents left to right. Won't do anything until you've done all the exponents. Then you'll do all the multiplications and divisions, and if there's more than one, you'll work from left to right. Now, I'm not saying you're going to do multiplication before division. They're on the same level, aren't they? If there's a multiplication and a division, and the division is leftmost, then you're going to do that one. They're on the same level. You're going to work amongst them left to right. Then after that, you'll do your additions and subtractions. A lot of people want to do them first because they're easier, but you don't get to. You have to do the multiplications and divisions first. Then finally, we need you to simplify any fraction. That's the order of operations.
I'll be back.
And it will be back. It's going to be, you're going to need to know that forwards and backwards throughout the whole rest of your math career. Your calculator knows it, but you'll need to know it. Actually, as I said, you'll need to know it forwards and backwards. You'll see it will be back. So, which do we do first here? Is it add the 5 and the 7 first? Or multiply the 7 and the 10 first? Well,
Not.
you got tempted to do that addition first, didn't you? But the order of operations tells you that you have to multiply, then add. So the answer to this question, you might be surprised, is 75. If you had put 120, you would be absolutely wrong.
Certainly. Allow me to demonstrate.
Let's look at an example. In this problem, we have to do the order of operations, which is parentheses, there aren't any. Then exponents, there aren't any. Then multiplications and divisions. Now we do have two multiplications, so we have to work our way from left to right. We'll do this one first, then we'll do this one, okay? We're not even doing addition until all those multiplications are out of the way. So we'll end up with 60, that's 12 times 5, plus 18, that's 3 times 6. Now that I've done all my multiplications and divisions, there aren't any divisions, I'll do the addition. Notice we're not working directly from left to right, are we?
Transfer of data is complete.
Now you're done.
All that little fire, Scarecrow.
Let's work our way through this one. We have to follow the order of operations, or we'll get an answer, it'll just be wrong. Order of operations you'll need to memorize is to first do what's inside any parentheses. So I'm going to do the 8 minus 5. I won't do anything else. I call this the circle method. I write everything else the same except do what's in the circle. So 8 minus 5 is 3. Okay, that's parentheses. Now I have to do any exponent. Let me circle that. 4 to the second power. We just covered that. What is 4? Don't you say 8. What is 4 to the second power? It's 4 times 4, 2 times. So I'll write everything else the same, except what's inside the circle will become 16. Now I've done parentheses and exponents. Now multiplication and division. There's a multiplication. There's only one. So I'll write everything else the same. I like to circle it and do what's inside the circle, 18. Now I've got some additions and subtractions. I have a couple of them. I kind of work either from left to right, or I should have said also from top to bottom. So we're going to add 2 and 18 and subtract 16 minus 6, and 2 and 18 is 20. 16 minus 6 is 10. We're looking at 20 over 10. My last step is to simplify this fraction. 20 over 10, or 20 over 10 is 2. Now I'm going to jump to one of the common applications of multiplication and exponents.
Pay attention, son. Look at me when I'm talking to you.
And that's going to be area. Area is measured by the number of square units, whether they be square feet, square yards, square inches, that are contained in a region. Now here's a region. The area of this rectangle is 15 squares. 15 square, well, we're going to say feet. It's probably 15 square inches. Now how did I get that? Well, I just counted. Okay, I was 15. I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But if you measure the width and the length of a rectangle, now this only works for a rectangle, hopefully you see there's a relationship between the width and the length and the area. Because if we have something like this that has 9 inches by 7 inches, and you're thinking to yourself, there's too many to count, well, you could count it, but you don't feel like it. You can use that relationship, and that is that the area of a rectangle is always the length times the width. That's a fast way to count the boxes. So the length times the width in this case saved me from counting all those squares is 63, and you have to say 63 squares, or 63 square inches. So that's the area of this thing. Remember that formula. Area is length times width for a rectangle. Well,
Are you pondering what I'm pondering?
let's consider the same formula for a square. A square is a rectangle, it just has equal sides. As you can see, you can count that that has 9 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it is in fact a square because the sides are equal. 3
I know that, dude.
by 3. Okay, the sides are the same. It kind of is length times width, isn't it?
Hey, wait just a minute.
But if you said that the length and the width were the same and called them sides, there's another way to write this. Instead of side times side, you may see side squared, which means 2 sides. Side times side, doesn't it? You know what exponents mean. You can see that it's going to be 3 squared, and what is 3 squared? But 9. 9 square feet. So if we gave you something like this, and we told you it was a square, we really only need to give you one side, because the other one's the same. And the area of this square is going to be side squared, or side to the second power, is 7 to the second power. Now don't you say 14. What is 7 to the second power? Is 7 times 7, 2 times. It's 49. And always say 49 square inches when you're measuring area, because that's what you're measuring, how many squares. Oh, Katie? Okay, you need to move it, bub, and do your homework.